Hello and welcome to section 3.9 differentials. In this section we're going to talk about how they use differentials to help you solve problems and use it as an approximation. So differentials are basically a little bit of an approximation of what's actually happening. So what they're saying here in a differential section, in this differential section, is that we are going to use a tangent line to represent what's happening on a curve. And so in real life, if we have a function that does something like this, and we were finding the slope of the tangent line at a particular point, we would be finding the actual change in y. And so that would be this guy right here. We're using delta x, delta y, but what we can do is if we make a tangent line that is pretty darn close to what's happening at that point, we can use an approximate change for y by using the derivative. And so these differentials are going to be off just by a little bit, but it's going to be such a small change that it's not going to matter. And so now when we're writing differentials, we're going to be writing them a little bit different. We're not going to use the delta x and the delta y's. We're going to use a little d and a little d in front of it, just kind of like when we were dealing with taking the derivative of functions. And so all of this is just a matter of that we're going to use it as an approximation for what's going on. And now this is a setup for what we're going to talk about in chapter 4 when we reverse this operation. So these little differentials are kind of important when we're going backwards. And so that's where this comes up. This is kind of the transition section. And so we'll talk about how it applies to tangent lines, the tangent line approximation of things, and stuff like that in class, and we'll practice this. But make sure you get this stuff down that we're going to be using an approximation for our differential, and we need to make sure that we get these definitions also. So then we calculating a differential. This is the way we did it in chapter 2. We could write things in differential form. If we went du over dx, we said it was u prime. Well, we're just kind of multiplying across the equal sign here. And so now by doing a product rule of the differentiation of u, we would say, oh, well, we're going to take the derivative of this and we'll take it with respect to x. So we end up with this, and this is basically following the product rule, distributing it out, getting rid of the x variable, the dx, and getting it in terms of dv and du. And so kind of copy this down. We can talk more about this in class, but this is basically what we're doing. So we have some rules that still apply, and that's where that was just kind of the setup for these guys, but they're the same rules that we've had before. So make sure you get these down, and we'll talk about it when we come to class. And so then, how does this work? Well, if I was to take the derivative of this function, I'd say dy dx, y with respect to x, would get me something like that. Well, the differential is just moving the dx across the equal sign, so it would look like that. That's it. And this dx we'll talk about is the slight change or the small change in x that we get, and we'll use that as for something in the next unit in chapter 4. Well, if I'm taking the derivative of 2 sine of x, I would get 2 cosine x. Well, the differential is going to be 2 cosine x dx. And that's really all it is. It's just going to be a change in notation. There is a little bit more to it than just the change in notation, but for us, that's really all we want to pay attention to, is the change in notation and where this is coming from, that we're dealing with a slight change from the actual value to an approximated value, and we'll talk more. So if I was to take the derivative of this would take the product rule, which would give me cosine x plus x times negative sine x, and so then that could simplify to cosine x minus x sine x. And so then the differential of this is just moving the dx across the equal sign, which means I would get cosine x minus x sine x dx, something like that. If I took the derivative of this, then I would end up with negative 1 over x squared, And over here, it might be written like this, negative dx over x squared, just because the dx is multiplied by the negative 1, and therefore it gets simplified to something like that. And so this is just the notation that we're going to be using, and we'll talk more about this in class. So if you have any questions, feel free to come to class and ask them. Make sure you get the properties down and the rules for differentials. And I'll kind of scroll through these again so you can kind of pause as needed to get them.